Okay, what we have here is a parameterized model of the clock. We had to specify the position of each component of the clock to make sure that they wouldn't overlap. It took a while to figure out the need for POS, that's position vector. So it's not position, it's POS. That was a hang up for a while. I couldn't really move the minute hand, hour hand, the minute hand, second hand, and hour hand where I needed them to be. If you were to actually 3D print this thing, we wouldn't want the hands to overlap. So we have a space for those. The pin makes it look a little more realistic. So we have a hub coming out of the center of the clock. These four statements lay out the tick marks. Those are all parameterized based on the length of the arrow, and so the size of the clock is based on the length of the arrow as well. Moving down here, we couldn't select a rate that would actually match up with how a clock should tick. So the best way to do it was to set it based on the local time here, and that equation was my time equals time.localtime parentheses time.time open close. And then when you hit print, you could see that it would spit out an array, and the third position in that array was the hours, the fourth position was the minutes, and the fifth position was the seconds. So by coming down here and printing those out, I could see what they were, and then having it in this loop would allow you to see it update in real time. The rate that this is updating is based on this rate of 10 right here. And then we needed it to take the number 7 and point that where 7 is on an analog clock. So we came up with this equation: theta hours 0.5 starts you off in the straight up position, and then the negative here tells it to count in the clockwise position. And so 2, calling this NP numpy, it's up here, numpy, calling numpy and multiplying by pi, so you have 2 pi, that's 360 degrees, and you multiply by the ratio of the hour hand because it's divided into 12 hours, and then I wanted to show the time between, move along with the minute hand, so it would also take into consideration the minute hand and divide that position by 3600. And we did something very similar for the angle for the minute hand and the angle for the second hand. So that'll update as the seconds update. The clock should tick. And these are the axes. The direction in which it points is based on these same angles. So, yep, I'll show you the clock here in a second. Okay, and here's the clock. You can see the hands do not overlap. So if you were to 3D print it, looks like it almost did overlap. So I might have to move that one up just a tad. So you have the hub here, each hour hand, minute hand. Your tick marks are just a little bit taller than the clock. It's all coming out of point 000, which is the back of the clock right here, 000. And so the clock thickness is here, the tick mark thickness is here. The minute hand length is this distance. Minute hand length is this distance, second hand length is that distance, hour hand length is that distance, and then it ticks on the marks based on what the clock is reading. So let's watch that again, see if there is overlap. Oh yeah. Okay, we'll move the green arrow down a hair, white arrow down a little bit, and we should be good. We have some room to move the red arrow up. Not really. Yeah, that's the plan. Okay, here's the final revised clock. We had to make the hub quite a bit bigger, and get all these arrows to fit in and not overlap. But it's necessary. But we have all our distances spaced out reasonably well. And so there you have it.